Hey guys, go ahead and check out the comic I've got and tell me if you can remember why that's particularly humorous. We've got the planets looking at the sun with some fair indignation, saying not everything revolves around you. And the sun saying, well, actually. Let's go back to what we remember from 6th grade, if you would. Back in 6th grade, you started studying the universe. We looked at space very, very carefully because for as long as humans have been around, they've wanted to understand their place in the universe, to look outside the window and to see that dark sky at night has always been something that has been a place of curiosity for us. So initially, this is before telescopes, this is before a whole lot of the technology that we use now. When humans would go outside at night and they would look at those stars, they came up with the idea that Earth was the center of the universe. And that made sense back then, if you think about it. Because as you stand outside and you look up without any assistive technology, it looks like everything else is moving over time and you're standing still. Because certainly we don't feel ourselves moving on Earth. So it was a very sensible early start to astronomy. They called that the geocentric theory of how the universe functioned. Geo, we know, means dirt or ground, earth. Okay, and that centric is the center. So Earth being in the center, you see where they got the verbiage from in those morphemes. So that was the idea that back then we thought everything revolved around Earth. And by everything, we mean the universe revolved around Earth. Now, Ptolemy was the scientist who basically came up with that idea. And people were very, very supportive about it because that made it seem like it was all about us and we were what we knew. So that made good sense to them. Now, over time, as science continued to develop, technology started to emerge. We had Copernicus come about around 1500, and he started to see things differently. And here we started a progression of ideas, and we started to come out with the emergence or the kind of the birth of a heliocentric theory on how what came to be known as the solar system, how the solar system functioned. Okay, so we had geocentric, the Earth was the center of everything. And now we're starting to have an emergence of ideas where maybe the Earth isn't the center, but possibly our star, our closest star, the sun, is the center of a solar system. Okay? So this heliocentric model talks about our sun being the center of a solar system. And again, this was a progression of ideas. We didn't go from A to B, boom. We had to figure out a lot of different things. And there was a tremendous amount of data to be captured. When you think about it, we're depending on people without a lot of scientific experience, without a lot of scientific technology, marking things that they're seeing in the sky and marking the dates and looking for the patterns and the progression and trying to figure out speed and all this other kind of stuff. Okay. And so Copernicus did his thing. And then over time, with a lot of study and a lot of data collection, we have Kepler, who came up with some rules. And what we basically figured out was that this heliocentric model, where the sun was the center of a solar system, you had planets that would move around that major star. Originally, people thought that they moved around in spheres. So if you could imagine the sun in the center here, and then you've got planets moving around in round spheres. But the math to that didn't hold up. So they came to understand that planets actually move in elliptical orbits, okay? Ellipses, like I'm kind of drawing out over here, ellipses. Now, we did have one problem, our problem that we could see Mars, and Mars would kind of follow all the math that we thought it should and follow this pattern. And then every now and then, about every 2 years, it would zigzag in an east to west sort of fashion, and it wouldn't follow its pattern. And you know, scientists, if something's going to work, it's got to work all the time for them to say, hey, this theory is solid. And so they had some problems with Mars and Mars falling into retrograde. And what would happen is the difference in the speed between Earth and Mars would sometimes have Mars ahead of Earth and sometimes have it moving behind the Earth. So when it did that zigzag, we called it going into retrograde. So now that we've had our happy little chat, it's time to show me you've got it. I want you to grab 3 coins. I want 1 to represent the sun, 1 to represent Earth, and 1 to represent Mars. You're going to create a model with these 3 coins of how the Earth and Mars orbit the sun according to the heliocentric theory. I want you using that word as much as you can, the heliocentric theory. And we're going to throw some extra points at you if you can also show and explain Mars in retrograde in your model. Thanks for watching. See you next time.